Hi, I'm Maya, and today we're going to be talking about quadricep group atrophy following ACL injury. We're going to talk about why it occurs and then also proper strength testing and balance testing, and then exercises to help mitigate that atrophy in ACL athletes. And this is part of my ACL portfolio research project. This is part 3 of a 5 video series. Okay, so arthrogenic muscle inhibition. This is why the quadriceps atrophy so greatly after an ACL injury. It's not just a disuse injury if I weren't to work out one of my quadriceps. This happens greater, as you can see in this picture down here. My surgical side is much less than my non-surgical side. The quad can just, the quad tone is not there like it is on the other side, even if I haven't used that one in a while. So this is a very common impairment with ACL injury. And quadriceps atrophy is greater than that disuse injury. It's a complex neurological impairment that comes from altered afferent information between the brain and the muscle. So, changes in the muscle function, and it also leads to a biomechanical deficit in strength and movement patterns following ACL tear, which can lead to deficits in rehab, which we want to address throughout all phases of rehab because this can be ongoing if it's not addressed and those neurological pathways aren't restored. There's also a suggested mechanism behind this that's to protect the joint following an injury. So, vastus medius, since the ACL, which that atrophy is greatest, since the ACL is torn, it's trying to prevent any complex movements from occurring, which could be why this happens. But the vastus medius and the glute medius are very important in ACL rehabilitation since they both atrophy and they can contribute to biomechanical deficits. So we will talk about those some more. So these are muscle EMGs. We put them on and they measure the electrical activity of the muscle. So you can see in this picture on the left, we have them on the VMO and the VL, which are the two major muscles in the quad. And then this you can see is just a relaxed picture. When I flex my quadriceps group, we can really see that definition of the VMO and the VL, just so that you know where to place it. And these are most commonly used in the research setting. They measure the electrical activity of the muscle. It tells us how active the muscle is. And then this is how you get it set up. This is just a screenshot from my computer that shows that I'm selecting the right side, which was my surgical side, vastus medialis, right side, vastus lateralis as well. So you can use these for a whole bunch of muscles, but we'll focus on these today. All right, so in this video, you can see that I'm contracting as hard as I can for about 2 seconds and then relaxing, and then contracting as hard as I can for 2 seconds and then relaxing. And then we can see on the screen what the readout is saying. It's giving us the rate coding of what happens inside the muscle when that contraction is occurring. So based on the graph results, that margin, that top line is going to show us 100% of muscle contraction. And when you're below that, it's showing us that there is some possible neurological deficits there. So it's that millivolt activation of the muscle, which is what we measure that neurological activation in. And then anything above that middle ground line is going to be concentric, so that shortening of the muscle, that contraction. And then when I'm relaxing, we can see that eccentric is what comes below that point. It really shows us if the muscle is active, but it's really important that pre-existing data is there. So using them over a series of time is going to be the most effective. So we would need possibly pre-injury data, or we could look at normative data for a healthy male or female of the same size, or we could also test the uninjured side to help this. But that pre-existing data is really important. We can also get a baseline at the beginning of a training program. So before we start working on that VMO, we could use these right at the beginning to see how we're increasing, what our activation was pre and post. We would test at certain times throughout that rehabilitation program. So, like I said, those peaks show 100%. Anything less than that is going to be a neurological deficit. And then for strength testing, we can see we can do a force plate squat test, which measures forces in newtons, and it's going to measure the concentric and eccentric force that the muscle is generating. And it's also going to measure limb asymmetry. So we'll just watch. I'm standing on the force plates here, and I'm just going to do 5 squat reps. So lowering down, back up. I'm trying not to favor my right side, that surgical side, as much as possible so that I can really get accurate data and just see how much I can challenge that leg. So there's that. And then we're going to talk about the results here. So this was my first rep, and we can see that the force dropped as the reps progressed. But this first one, I'm at 710 newtons with 21% asymmetry. So I'm really favoring that right side. And then you can see that I dropped, my negative displacement was only 24.2 centimeters. So that's how low my squat was. And then concentric peak power is just going to be how much I generated. This is going to be the second rep. You can see that I generated a little bit more force, went a little bit lower. My asymmetry actually dropped to just 16%, and that concentric peak power actually went up as well, which is just due to that greater negative displacement. This third rep is interesting because I go way deeper in this one. You can see I went from 25 centimeters to 60 centimeters, almost 61 deep. And that just shows that more eccentric force to hold that deeper squat is needed. So that eccentric force is going to be greater, and then that concentric force to pull me back up is going to be even greater. So 7.55 with 679 newtons of force to pull me back up out of that squat. Those other three reps were around the same values, but this is going to be the one that's really shown to be the greatest. And then this is just the last one. You can see very similar to the first reps. But obviously, my asymmetry in all of these reps is favoring my right, which makes sense because it's the injured side, but that's really what we're addressing with these next couple exercises. Okay, so something that you can do to assess glute med strength, the glute medius really provides stability in single leg movements, which prevents knee valgus. A strength insufficiency can lead to difficulty in dynamic single leg exercises, overall balance, and gait pattern. And a hip drop can occur, which we'll talk about in a second. And then the vastus medius also controls patellar tracking, knee joint alignment, and quadriceps force production. And any neurological inhibition, like the AMI that we were talking about, is going to have an altered lower limb biomechanics, and it's seen from significant atrophy of that VMO, and it makes it difficult to regain range of motion and control functional movements, which we'll talk about in this movement. So, in this single leg squat test, we're looking at 2 points on the hips, the ASIS on both sides, and we're just seeing if that hip drop is occurring. So this is obviously a really short step, but you can see even a hip drop's occurring in this. When I put the 2 points on the ASIS, my left hip is dropping, which can show some glute med weakness. We don't want that to occur, so glute med strengthening is going to be the best way to counteract that. This can be seen in a gait test as well, gait analysis. Just walk on a treadmill, record yourself. If that hip is dropping a lot, that can show glute med weakness as well. And then in terms of other postural things, we're also just looking at that knee valgus, which can occur from this altered hip drop, glute med weakness. In this picture, we're not seeing anything crazy, which is awesome, but we still want to address that. I've seen a lot of internal rotation throughout my ACL recovery, which is something that we're addressing through that external rotation with that glute med strengthening. All right, so first we're going to talk about vastus medius exercises that mitigate and reverse that atrophy. This first one's just going to be a step back. Again, we do want to keep those hips in line. So hands on the hips is a good way to tell if that's occurring, that drop is occurring. And then you just want to focus on that external rotation can be a good cue for athletes, and just lowering through a hip hinge as well. Just do a couple reps of that. Back up, pushing through that quads group. Oops. And then the second exercise is going to be a 3-way lunge on a foam pad. And this exercise challenges balance and single leg stability at the same time. And since the glute med and vastus medius are so important in that single leg stability, this is really going to challenge it in different ways. So we're just going to go to the front little squat. This doesn't have to be super deep. As the athlete progresses, it will get deeper. Out to the side, and then the back diagonal direction. And we also want to make sure that that trunk stays super upright during this, because the glute med weakness will also contribute to some of that trunk tilt, which we want to mitigate by keeping that core tight as well. And then these are some specific glute medius exercises. This one's going to be an isometric clamshell just against a wall. So we want to plant that one leg, and then we're just pushing out and holding for about 30 seconds on this one, or until fatigue sets in. So you can just see isometric. Doesn't look like much is happening, but I promise it burns and increases strength. And then the second one's just going to be an abduction with a slight external rotation, which is shown to activate the glute medius more because of its origin and insertion points. You can see that one, just rotating slightly outwards as we go, keeping that torso again upright as possible. And then some balance exercises. This first one's just going to be an isometric squat on the Bosu ball. So single leg, we're just focusing on controlling that. You can see as that knee kind of shakes, starts to cave in a little bit, we need that glute med to pull it back outwards. Those are going to be around 30 seconds as well, or until fatigue. This exercise brings in some rotation. It's like a rotational on the foam pad, squat, and a hip hinge at the same time. So putting weight outside of our trunk really challenges the core and the glute med and VMO to co-contract and keep you from leaning or falling out to the side. You can see the athlete's really working to control that the whole time. Sometimes, yep, that toe's got to go down, but really recenter and work on that. This one's a good one. And then this last one, let's get this last one, I use this one in the other video as well. This is that three-way lunge. It's also really good for balance because of all those things having to co-contract together. All right, and then these are just a couple of the biomechanical improvements that are really important in optimizing return to sport and preventing any re-injury of the ACL. Strengthening the glute med and VMO during ACL rehab are extremely important for that single leg stability and return to sport. In early phases, that arthrogenic muscle inhibition really causes that quad to atrophy, and that needs to be addressed quickly and continued throughout the program to prevent re-injury as the athlete returns to sport as well. So, yeah, thanks for listening. These are some of the resources we use today in those neuromuscular reevaluations if you wanted to take a look at some of the specific things that I said.